Hello everyone, this is Gokul. Currently, I am pursuing my Masters in Computer Vision at Mohammed bin Zayed University of Artificial Intelligence in Abu Dhabi. With my classmates Abhishek and Sahal, and with my supervisor Dr. Karthik, I worked on this project called MuCoT, which expands for Multilingual Contrastive Training for question answering in low-resource languages. For this work, we focus on multilingual question answering. So the term multilingual in this context means the model has to solve the question answering in multiple languages. In question answering, the input has context and question. So the task here is to locate the answer to the question in a given context. So let's look at the problem of the existing methods. The accuracy of English language question answering systems has improved significantly in recent years with the advent of transformer-based models. Multilingual BERT-based models like mBERT are often used to transfer knowledge from high-resource languages to low-resource languages. But directly training an mBERT-based question answering system for low-resource languages is challenging due to the paucity of training data. So we augment the question answering samples of the target language using translation and transliteration into other languages and use augmented data to fine-tune the mBERT-based QA model, which is already pre-trained in English. Our experiments on the Google ChAll datasets show that fine-tuning the mBERT-based model with translations from the same language family boosts the question answering performance, whereas the performance degrades in the case of cross-language families. We further show that introducing a contrastive loss between the translated question context feature pairs during the fine-tuning process prevents such degradation. So we have picked mBERT as our baseline. The main idea behind BERT is they have utilized large amounts of unlabeled data with a self-supervised task of next sentence prediction and masked language modeling. When this BERT is pre-trained on multilingual data, it is referred to as mBERT or multilingual BERT. We have taken this mBERT and pre-trained it on SQUAD dataset. SQUAD is a large-scale question answering dataset in English. Then we did translation and transliteration of our target data ChAll to increase our training data records. Previous research work has shown that languages under the same family have shown similar representations in multilingual models. With that point in mind, we put together translations and transliterations from related languages within the same language family to achieve better performance. We observed that same language family QA performance got improved, but the cross-language family QA performance got degraded. So in order to encourage similar representations for the same content across languages, we introduced contrastive loss. For this, we first compiled the pair batch. For each item in the original batch, we picked an item with the same content but in a different language. Now we got two batches, pair batch and original batch. We passed these two batches in parallel to the same encoder. Then we did global average pooling to get the representations for the original batch and the pair batch. So here in this figure, each of the OA or PJ corresponds to a vector. And from these two vectors, we did multiplication to get this Logit's matrix Q. So each cell in this matrix is the result of a dot product of two vectors, one from the original patch, one from the pair batch. For example, O1 P1 is a scalar that is computed as a result of the dot product between the vectors O1 and P1. Then we computed the contrastive loss similar to the clip paper. So that is done by computing the cross-entropy loss for each row and each column in this Logit's matrix with treating the cells along the diagonal of this matrix as our target classes. Then we added this loss with the original loss and fine-tuned it together on our target dataset. So this figure summarizes our whole proposed pipeline. First, we took the mBERT model that is pre-trained on large-scale Wiki100 dataset. Then it is pre-trained on SQUAD dataset, which is a large-scale question answering dataset in English. Then we added the translations of our target dataset ChAll in different languages. Then we optimized this model based on the combination of question answering loss and the contrastive loss that we showed previously. Here are our results. The table at the top corresponds to translation and the table at the bottom corresponds to transliteration. So if you look at the transliteration table, even though the performance got improved with transliterations, the pattern is not uniform. This might be because none of the pre-training techniques have dealt with this kind of transliterated data. So let's focus on the translation table. So the first column corresponds to your baseline. So it got an overall Jaccard score of 0.44 that has no SQUAD pre-training, no translation, and no contrastive training. When we introduced SQUAD pre-training, the performance went up from 0.44 to 0.5. Then we included the translations from the Dravidian language families, Malayalam and Telugu. You could see that the overall performance almost remained same. But if you look at the individual performances, Tamil performance actually went up from 0.37 to 0.44, but Hindi performance went down. Then we introduced contrastive loss. So you could see that it prevented the degrade with Hindi. It also maintained the Tamil performance, resulting in the overall performance improvement. With internet usage expanding every day, there is an increasing need to develop better NLP models for a variety of downstream tasks in vernacular languages. As most of these languages do not have labeled resources that are sufficient enough to train standalone modern deep learning models, we need to rely on multilingual models and enhance them. Our work is a step in this direction, and it is an attempt to understand and evaluate the impact of cross-language knowledge transfer through pre-training and fine-tuning. We hope our insights will be useful to the low-resource NLP research community, and the same phenomenon of cross-lingual transfer in other multilingual models, language families, and multilingual tasks will also be explored. Thank you.